In this session, we are going to discuss about time and distance. This is again an important topic from quantitative aptitude, where we are supposed to work on the relationship between time and distance. Now, in general, here we have got three different terms. That is speed, which is generally denoted by S, distance, which is denoted by D, and time, which is denoted by T. Speed can be defined as the rate at which the distance is covered, and we can calculate speed as distance travelled by time taken to travel the distance, or simply we can say speed is distance by time, or it can be taken as speed equals to distance by time. So this is the basic relationship between speed, distance and time. Speed is equal to distance by time. From this equation, we can have two more equations, one for distance, the other one for time. For example, from this we can say that distance will be equal to speed into time, and also time is equal to distance by speed. So out of these three variables, any two will be given to us, and we are supposed to find out the third one. So we can use any one of these equations accordingly and try to get the answer. From the basic equation of speed, distance and time, that is speed equals to distance by time, the various points that we can make out are: when the time is constant, speed directly varies with the distance. When the time is fixed or the time is constant, that means to cover larger distances we should have higher speeds, and to cover smaller distances we should have smaller speeds when the time is constant. Similarly, we can say that speed is inversely proportional to time when the distance is constant. For example, to travel a given distance, speed inversely varies with the time. Higher the speed, lesser will be the time taken. Lesser the speed, higher will be the time taken. And when the speed is constant, we can say that distance is proportional to time. So when the speed is fixed, the distance and time directly varies with each other. Therefore, as the distance increases, the time also increases. As the distance decreases, the time taken to cover the distance decreases. So these are the three relationships that we need to understand. The first one is speed is proportional to distance when the time is constant. Speed is inversely proportional to time when the distance is constant, and distance is directly proportional to time when the speed is constant. Let us now look at the various units of measurement for these variables. For example, if we take the distance here, it is nothing but a length, and length can be measured in a number of ways. For example, it can be measured in kilometers or meters or centimeters or inches or yards. And similarly, time can also be measured in a number of units. Time can be measured in seconds, minutes, hours, days, etc. And accordingly, we will get a number of units for the measurement of speed. For example, if the distance is in kilometers, time is in hours, speed what we get will be in kilometers per hour. Similarly, if the distance is in meters, time is in seconds, the speed what we get will be in meters per second. And in case if the distance is in kilometers and time is in seconds, the speed will be in kilometers per second. And accordingly, we can have many more units of measurement of speed. But in general, all these three variables are measured with two standard units. For example, when it comes to distance, it is generally measured in meters or kilometers. Time is generally taken in seconds or hours. And accordingly, the speed what we get can be measured in two standard units. One is meters per second, the other one is kilometers per hour. So these are the various units of measurement which are generally used in calculations. And one point which should be taken care of when we are solving questions from time and distance is that units must always be balanced on both the sides. For example, if the distance is in meters and time is in seconds, the speed what we get will be in meters per second. And similarly, if the distance is in kilometers, time is in hours, speed what we get will be in kilometers per hour. So this should always be balanced. In case if the distance is given in kilometers and time is given in seconds, so as you can see, distance in kilometers and time in seconds. So if we directly take these units, the speed what we get will be kilometers per second, but that is not a standard unit of measurement. So what we need to do here is either convert kilometers to meters and get the speed as meters per second, or convert seconds to hours and get the speed as kilometers per hour. So it is very, very important that whenever we solve questions from time and distance, units have to be balanced on both the sides before we do the calculation. So let us first understand how to convert these units from one form to the other. For example, how to convert kilometers to meters or meters to kilometers, and likewise how to convert meters per second to kilometers per hour, and so on. Now let us start with distance. We know that 1 kilometer is nothing but 1000 meters. So this is how we can always convert kilometers to meters or meters to kilometers. So suppose the distance is 2 kilometers, it will be 2000 meters. If the distance is 3.5 kilometers, it will be 3.5 into 1000, that is 3500 meters. So whenever we have to convert kilometers to meters, we can multiply the given value with 1000. And whenever we have to convert meters to kilometers, we can divide the given value by 1000. Let us now look at time. Time in general, if we take it as 1 hour, it is nothing but 60 minutes. And each minute has got 60 seconds. So total number of seconds will be 60 into 60. That is nothing but 3600 seconds. So with the help of this equation, we can convert the various units of time. 1 hour is 60 minutes. So 2 hours will be 120 minutes. That is nothing but whenever you have to convert time from hours to minutes, multiply with 60. For example, 3 hours can be taken as 3 into 60, 180 minutes. And whenever we have to convert minutes to hours, we need to divide by 60, because when 60 goes on the other side, it comes in division form. So 1 minute can be taken as 1 by 60 hours. So suppose the given time is 120 minutes. If we divide by 60, we can convert that to hours. That is 120 by 60 is equal to 2. So 120 minutes is equals to 2 hours. So this is how we can convert hours to minutes or minutes to hours as required. And similarly, we can use 1 hour as 3600 seconds and convert hours to seconds or seconds to hours as per the requirement. Let us now look at how to convert the speed from one unit of measurement to the other. Right? For example, let us assume the given speed is 1 kilometer per hour. Let's understand 1 kilometer per hour will be how many meters per second. Now, as you can understand here, 1 kilometer per hour indicates that the body can travel a length of 1 kilometer in 1 hour. So this is nothing but 1 kilometer in 1 hour. Now we know that 1 kilometer is 1000 meters. So this can be taken as 1000 meters divided by 1 hour is 3600 seconds. So 3600 seconds. Now if we try to simplify this, this is 200 into 5 and this is 200 into 18. So very clearly this is 5 by 18 meters per second. So we can understand that 1 kilometer per hour is equals to 5 by 18 meters per second. So whenever we have to convert kilometers per hour to meters per second, we should multiply the given magnitude with 5 by 18. And from this we can understand that 1 meter per second will be equal to, if we take it to the other side, it gets 18 by 5. 18 by 5 kilometers per hour. So this is how we can convert meters per second to kilometers per hour. That means whenever we have to convert the given value meters per second into kilometers per hour, we should multiply by 18 by 5. Or if we have to convert kilometers per hour to meters per second, we have to multiply by 5 by 18. So this is 5 by 18 meters per second. Let us take an example to understand this. For example, let's say the given speed is 72 kilometers per hour and we have to convert this into meters per second. That is 72 kilometers per hour is how many meters per second? Now from this we know that 1 kilometer per hour is equals to 5 by 18 meters per second. So if you multiply the given magnitude with 5 by 18, kilometers per hour gets converted to meters per second. So this can be taken as 72 into 5 by 18 meters per second. So 18 here goes 4 times, 4 into 5 is 20 meters per second. So 72 kilometers per hour is same as 20 meters per second. And let us now take an example where we convert meters per second to kilometers per hour. Let's say the given speed is 15 meters per second and we have to convert this to kilometers per hour. We know that 1 meter per second is 18 by 5 kilometers per hour. So whenever we have to convert meters per second to kilometers per hour, we can simply multiply the given magnitude with 18 by 5. So 15 meters per second will be equal to 15 into 18 by 5 kilometers per hour. So 5 here goes 3 times, 3 18s is 54. So this is 54 kilometers per hour. So we can say that 15 meters per second is 54 kilometers per hour. So friends, this is how you can convert various variables here from one form to the other. Right? And this is very important because whenever we solve a question from time and distance, before we do the calculation, the units have to be balanced. So always make sure that the units are same on both the sides and only then you proceed for the calculation. Let us now take the first model from time and distance where we shall solve some basic questions on the equation speed equals to distance by time. Let us look at the first example here. The question is, a bus covers a distance of 216 kilometers in 4 hours. What is the speed of the bus in meters per second? So as you can see here, very clearly the distance is 216 kilometers and the time taken is 4 hours. And we are supposed to find out the speed of the bus in meters per second. We know that speed is equal to distance traveled by time taken to travel the distance. So here we can say the speed will be, the distance is 216 kilometers and the time is 4 hours. So here we get the speed in kilometers per hour. So this is 4 into 1 and 4 into 54. So clearly the speed is 54 kilometers per hour. But as given in the question, we are supposed to find out the speed in meters per second. So let us convert this speed of kilometers per hour into meters per second. As we have discussed earlier, 1 kilometer per hour will be equal to 5 by 18 meters per second. So with the help of this equation, we can convert the speed into meters per second. So whenever we have to convert kilometers per hour to meters per second, we can simply multiply the given value by 5 by 18 to get the required answer. So this 54 kilometers per hour can be taken as 54 into 5 by 18 meters per second. Now 18 here goes 3 times. So 3 into 5 is 15 meters per second. So the answer for this question will be 15 meters per second. Let us now take another example from model 1. The question here is, a man walks at the speed of 5 kilometers per hour and runs at the speed of 10 kilometers per hour. How much time will the man require to cover the distance of 28 kilometers if he covers half of his journey walking and half his journey running? So as given in the question, the total distance to be covered is 28 kilometers and the man covers half of his journey, that is first 14 kilometers by walking and the remaining 14 kilometers by running. So we need to find out the total time required by the man. We also know the speed of the man when he is walking, that is 5 kilometers per hour, and his speed while running will be 10 kilometers per hour. Let us see how can we solve this question. We know that speed is equal to distance by time, or from this we can say time is equal to distance by speed. As you can observe here, the total journey is covered into 2 halves. So we can say that there are 2 periods of time. In the first time period, the man walks, and the other time period, the man runs. So the total time required can be taken as time for walking plus time for running. And as we know that time is distance by speed, we can simply say that time for walking is distance which he covers by walking divided by speed of walking, plus again time is nothing but distance by speed. So time for running will be distance that is covered by running and the speed when the man runs. And we have got all these 4 values. So simply by substituting in this equation, we can get the required answer. We know that the distance which the man covers by walking is 14 kilometers. That is nothing but the first half of his journey. So 14 divided by the speed of walking is 5 kilometers per hour divided by 5. Plus the distance which he covers by running is the remaining half, that is the other 14 kilometers divided by the speed while running is 10 kilometers per hour. So this should be divided by 10. If we observe here, the distances are given in kilometers and the speeds are given in kilometers per hour. So obviously the time which we get from this will be in hours. So we need not convert anything here and we can directly proceed for the calculation. So 14 by 5 plus 14 by 10. If we simplify this, 10 is the LCM, 5 goes 2 times. So 2 into 14 plus 10 is 1 time. So 1 into 14. So that is 28 plus 14, 42 by 10. So we can say that the total time required is 4.2 hours. Let us now take an interesting example based on model 1. The question here is, a man takes 6 hours in walking to a certain place and riding back. He would have taken 2 hours less by riding both ways. What will be the time required by him to walk both the ways? The first statement here is, a man takes 6 hours in walking to a certain place and riding back. That means man here is covering a distance between 2 points. So while going from one point to the other, that is while moving from first point to the second point, he walks. But in the return journey, that is from point 2 to point 1, he rides. And the time taken is 6 hours. So we can say that the time taken for walking plus time taken for riding is equal to 6 hours. Remember friends, the distance which is covered while walking and while riding is equal. Why? Because he is moving between the same 2 points. The second statement here is he would have taken 2 hours less by riding both the ways. So in case if he rides from point 1 to point 2 and rides again from point 2 to point 1, he will take 2 hours less. So very clearly the time taken for riding and again the time taken for riding the same distance will be equal to 2 hours less than the previous time. So earlier he took 6 hours, this time he will take 2 hours less, that is nothing but 4 hours. So we are supposed to find out what will be the time required by him to walk both the ways. Let us see how can we get the answer here. First of all, we know that from this equation, twice the time taken to ride will be equal to 4 hours. So very clearly the time required to ride will be 2 hours. That means if the person rides from one point to the other, the time taken will be 2 hours. So if we substitute this time of 2 hours in the first equation, we can say that time taken to walk plus 2 hours is equal to 6. So from this, the time taken to walk one side of the journey will be 6 minus 2, 4 hours. So as you can see here, from the two equations, we are able to find out the time taken to ride one side of the journey and the time taken to walk one side of the journey. And the question here is, what will be the time required by him to walk both the ways? That means if he is walking both the ways, from point 1 to point 2, he walks, and point 2 to point 1 back again, he walks. So if he is walking both the sides, how much time is required? Very clearly, the time required to walk both the ways should be double of this time. Why? Because this is for one side 4 hours. So for two sides, the time required should be 8 hours. So we can say here that the time taken to walk both the ways, if he walks both ways, will be equal to twice the time taken to walk one side. So 2 into 4, 8 hours. So the answer for this question is 8 hours. Remember friends, strictly speaking, the paperwork is not required. If you have understood the concept here, this question can be answered without writing any of these steps. Why? Because we simply know that to walk and to ride equal parts of journey, the time taken is 6 hours. And to ride both the sides, the time taken is 4 hours because it is 2 hours less. So for one side of the journey, the time taken to ride will be 2 hours. That is 4 by 2, 2 hours. And if we take these 2 hours in the first case, it is very clear that the time required to walk was 6 minus 2, 4 hours. So for one side, if it is 4 hours, for both the sides, it has to be 8 hours. So try to be smart and answer these type of questions without doing any paperwork. Let us now discuss the second model from time and distance, where the distance traveled in two different cases are equal, but the speeds and the time are varying. Let us look at the first example. A cyclist travels a certain distance in 6 hours at a uniform speed. In the return journey, he increases his speed by 2 kilometers per hour and covers the same distance in 5 hours. What was his speed initially? So as you can see here, initially the cyclist travels a certain distance in 6 hours. So the distance covered is in 6 hours at a uniform speed which has not been specified. In the return journey, he increases his speed by 2 kilometers per hour. So there is an increase in his speed in the return journey and covers the same distance. Remember friends, this is the most important part of the question, that the cyclist is covering the same distance in the return journey. And that is done in 5 hours. So we need to find out the initial speed of the person here. Now as given here, the distance covered in the two cases is equal. So we can say that d1 is equal to d2. That is nothing but the distance in the first case should be equal to distance in the second case. Now we know that distance is nothing but speed into time. So d1 can be taken as s1 into t1 and d2 can be taken as s2 into t2. Where s1 and t1 are the speed and the time initially, and s2 and t2 are the speed and the time in the return journey. Now we need to find out what is the value of s1, that is the initial speed of the person. Let us substitute the remaining values and try to get the answer here. So S1 is S1 as it is. Now, as given in the question, the distance was covered in 6 hours in the first case. So T1 is nothing but 6 hours, which should be equal to. S2 is the speed in the second case. The question says in the return journey, the speed was increased by 2 kilometers per hour. That is nothing but S2 should be equal to initial speed plus 2 kilometers. So this can be taken as S1 plus 2, as the speed has been increased by 2 kilometers per hour. And the distance was covered in 5 hours. So T2 is nothing but 5. So by simplifying this equation, we can find out the initial speed. So So here 6s1 is equals to 5s1 plus 2 into 5, 10. So from this we can say that at the initial speed 6s1 minus 5s1 should be equal to s1 will be equal to 10, and that is nothing but 10 kilometers per hour. Why? Because the units here mentioned in the question are kilometers per hour. So we can say that the speed that we have obtained is 10 kilometers per hour. So friends, this is how we can solve these type of questions by simply equating the distance in the two different cases and finding out the required answer. Let us now take the second example from model 2. The question here is, a student walks to school at the rate of 2.5 kilometers per hour and reaches 6 minutes late. Next day, he increases his speed by 2 kilometers per hour and then reaches school 10 minutes early. What is the distance of the school from his home? So as we can see here, there are two cases. In one case, the student walks at the speed of 2.5 kilometers per hour and he is late to his school by 6 minutes. The next day, he increases his speed by 2 kilometers per hour. That means his new speed, the second day, is 4.5 kilometers per hour. 2.5 plus 2. So when he walks at the speed of 4.5 kilometers per hour, he reaches the school 10 minutes early. And we are supposed to find out the distance of the school from his home. Let us assume that the right time to reach the school is t. That means every day the school starts at time t. Let us assume the time taken in the first case is t1 and that in the second case is t2. So as you can see here, in the first case he reached the school 6 minutes late. That means from the time t1, if we subtract 6 minutes, we will get the right time t. So t can be taken as t1 minus 6. And in the second case, when he increases his speed by 2 kilometers per hour, he reaches his school 10 minutes early. That means if the time taken in the second case is t2, to that time t2, if we add 10 minutes, then we get the right time t. Because he has reached early, he is before the right time. So if we take 10 minutes more, we get the right time t. So we can say that the right time t is also t2 plus 10. Right? If you can observe in the first